Uh, First of all, very good morning to you. And my name is Satish Singh. I am studying in IIT Rourkela, currently pursuing as a PhD scholar, my PhD over there. And I have been selected for the Researcher Award, Best Researcher Award by the International Chemistry, Research Chemistry Award. Thank you for giving me this opportunity. And my entry ID is 1258. And one of my topic by which I have been selected was studies of the hybrid composite area CPP2 for effective defluoridation from water. And this is the topic which I have been selected for. And these are the various contents which I am going to discuss about these topics. First is introduction, which is the gap, materials and synthesis, characterization, conclusion, future scope. Fluoride. As we all know that it is having its atomic number is 9 and it exists in our periodic table with atomic number 9, and it exists in the nature in the form of fluoride minus ion, and below it has certain permissible limit which is set up by different agencies such as the European Union, and WHO has set it up to 1.5 ppm for the human level, and USFDA has set it to 4 ppm, and Indian standard has set it to 1 ppm. These are the different permissible limits which is quite useful for humans. Below above that, it can cause to have serious concerns in human body. So there are certain concerns which we have looked upon to. These are the various fluoride hazards. We could see that fluorosis is one of the major causes. Osteoporosis, which is lead to some bending in the bones, brittle bones, arthritis, and it has been seen in some cases of cancer that fluoride is also responsible for it. Sometimes thyroid disorder is also observed. Alzheimer's syndrome is also observed. And sometimes it has been observed in the enzymatic poisoning in aquatic animals, which sometimes actually fluoride also uh, integrates with the enzymes of those at some aquatic animals, which lead to some few uh, disorders. And physiological and biological and structural damages in plants could also be observed, as we could look the leaves of some plants as the water which has been uh, traveled from roots to shoots. The leaves in which the water is present, here we could see some structural damages could be observed. So further, as we look at what are the different sources of fluoride uptake, as we know that water is the vital part for the sustenance of human life, there are different sources of fluoride by different sources by which fluoride can be ingested. And today we all know that water is very limited, and drinking water is very limited for us. And day by day we are using water, which is whose quantity is very limiting these days. So we have to be very careful by using those drinking water, which is sometimes contain very different pollutants. And these are the various sources of fluoride uptake that different containing different contaminants. One of those contaminants is fluoride. So these are the various sources such as water. By means of we could intake fluoride in medicines, food and drinks, soil, air, cosmetics. So these are the different sources of by which we could obtain fluoride. So now we come to the point, what are the different processes by which we could remove fluoride from water. So till then there are four major processes by which we could remove fluoride from water. There is first is adsorption, uh, second is precipitation method, by which means we used to put some salts and materials by which they bind with fluoride and they coagulate. And third is ion exchange method, in which some few ions are being exchanged as a result of fluoride. And one of the method is membrane process, by which certain membrane has been used in electrolytic dialytic processes, and which fluoride can be separated. So among all those, um, adsorption technique is quite better regarding all those techniques. So we would look into why is adsorption technique is better. It's comparatively best with respect to this because it has much advantages and least disadvantages. Each and every technique has few pros and some cons. So is does the adsorption. So here, what are the pros and cons? We will discuss. It's cost effective. It's easy to operate. It has high binding efficiencies. It's applicable over a wide pH range. has high reusability, high quality of product that can be produced by means of adsorption. Few cons are also being observed. Has low selectivity and the disposal of exhausted adsorbents. These are few cons which have been observed in adsorption. So the different materials till then that has been used for the removal of the fluoride are given as some industrial waste and natural mineral-based adsorbents are also synthesized for the removal of fluoride. Few biomass-based adsorbents are also used. Metal oxide-based adsorbents, metal hydroxide-based adsorbents, carbon-based adsorbents, and few nanomaterial-based adsorbents are also used. These are the different types of materials till then which have been used for the removal of fluoride. So our focus is mainly on the benefits of metal oxides and the use of hybrid materials for the separation of fluoride from the water. So why these use of metal oxides and hybrid materials? Harmful ions are easily removed by using metallic oxides. Removal of nitro compounds and iodides are also possible for removing these use of these oxides and hybrid metals. Removal of anions and oxyanions. Bimetallic oxides are easy to synthesize, which is very cost effective. And among all those metallic oxides, we prefer to use rare earth-based metallic oxides. So they do have highly specificity towards fluoride. Most prevalent and less expensive rare metals has been chosen for the successful and efficient removal of fluoride. These have excellent fluoride removal tendency. They have very low solubility both in acidic and basic water. So in both medium their solubility is quite low, so due to which it is easy to separate, easy separable, available in large number of active sites. So they have large number of active sites by which the fluoride can be bound and less amount of material could be required for the removal of the fluoride. So these are the few literature surveys which has been done. So morphology dependent celia which has been synthesized via hydrothermal processes having 71.58 and 7 nano absorption capacity by different morphology. This celia has been synthesized by Kang et al. And these are several others literature survey which has been done. Zirconium lanthanum, polypyrrole, ceria silicate, ceria aluminate, ceria magnesium based magnesium iron based LDH, ceria silica, ceria zirconia, cerium 4 incorporated over iron 3 hydroxide with 3D yttrium based graphene oxide using sodium iron. These are various literatures which has been surveyed by us. So now whatever we have synthesized, that is seriopolypyrrole. So first of all we have used cerium nitrate which is dissolved in water for 15 minutes, and further it has been added to it. Sodium trisodium citrate has been added to it, dropwise. Further zero gel is formed and further it is grounded and annealed, and it has been kept in a muffled furnace for about 500 degrees Celsius for 2 hours, and the whole process is known as a Pechne's method. So it is synthesized by a Pechne's method, and nearly spherical ceria particles are being synthesized. Similarly, now ceria particles are sonicated in a water containing 0.1 molar HCl solution, which has been sonicated, and after that pyrrole is added dropwise to it. Further, ammonium persulfate as an oxidizing agent is added to it, which oxidizes polypyrrole, and these polypyrroles used to set up around the ceria molecules in which it has encapsulated these ceria particles around which a layer of polypyrrole has been set up. So as could be observed in the synthesis strategy mechanism. So further we have characterized HID and FTIR spectra has been analyzed. As we could see over here, this is the HID of pristine ceria particles, and these are the various planes including it, and 111 at 28.9 degrees Celsius to theta degree, in which we could observe this is the characteristic intensity. So here we could see that as the content of polypyrrole has been increased, there has been a slight shift in the peak we could be observed. So this again confirms with the successful synthesis of serious polypyrrole 1. So nearly we have synthesized three material in which 1 ml polypyrrole and 2 ml and 3 ml polypyrrole has been added to it. So these are named as CPP1, CPP2 and CPP3, and this is the XRD of pure polypyrrole. It is amorphous in nature, so we have got such a shape. So and the crystallite size, which was found out to be using Serrer equation as 8.92 nanometer. So again, that FTI spectra has been analyzed of Syria polypyrrole. So we could be observing over here, this is the TI spectra of pure pristine stevia. This is the TI spectra of pristine polypyrrole. This is the TI spectra of CPP2, and this is of CPP2S. So here we could be observing that this is the CPP2 before fluoride removal, and this is the spectra of CPP2 after fluoride removal. So here we could see that at 1041 116 expert to COH bending and stretching vibrations. So these stretching vibrations which have been we could be seeing that there has been intensity has been lowered, which means that successful incorporation of fluoride by exchange of hydroxide ions has been taking place. So here we could also see that the OH minus ion, which is nearly having a peak intensity of about 3220 centimeter inverse, stretching vibration with whose intensity has been sufficiently reduced, which might be due to the successful replacement of the exchange of fluoride ions with respect to hydroxyl ions. So these tells us the conformation of the fluoride absorption in the IR spectra. So in order to look into the surface morphology, both SESM and SEM and TM analysis has been done. So here we can be looking at that these are the polypyrrole structures. Polypyrrole structure is having a spherical morphology. This is Syria and this is CPP2 and CPP2 particles, and further we have analyzed the morphology using the TEM. So here we could be seeing that we have spherical morphology and the acidity pattern suggesting that it has polycrystalline nature. And before absorption, we could be seeing that Syria, fluorine, Syria, oxygen, carbon, and all these materials which could be observed over here. And after that, fluoride peak could be observed over here. So here the atomic percentage of fluoride after absorption could also seen in this EDS spectra, and a peak of fluoride could also be observed in the EDS spectra after the absorption of fluoride. So it again affirms that the successful defluoridation has been taken place by the material. Further, in order to analyze the porosity and the surface area behavior, so BET was done, and the surface area of CPP2 was quite higher with respect to pristine polypyrrole in Syria. So here we could see the polypyrrole has a surface area of about 131.22 meters per gram. Syria has 63.23 grams. CPP2 has 145.35 meters square per gram, and CPP2S. After the absorption of fluoride, so the material was named as CPP2F, and it has 135.44 meter square per gram. So here we could observe that slight decrease in surface area could be observed, so which might be due to the change in the surface structures upon the absorption of fluoride that has been taken place. So and the CPP2 is quite microporous in nature, because as we could see that the most of the pores that lies in the region between 2 to 50 nanometer. So it's microporous in nature, and decrease in the surface area and the surface pore volume, which also affirms the structural changes in the CPP2, as we could have observed that there is a slight change in the surface area after the post-fluoride absorption by CPP. Batch absorption results. So few batch absorption results were conducted, and we have seen that the dosage has been varied from 2 to 10, 5 milligram to 100 milligrams. So we can see that as the percentage of dosage has been increased, the fluoride removal capacity has increased, and after a certain point, it has reached to its saturation point. So we have fixed nearly about 40 milligram as the um, dosage quantity, which is to be carried out in further batch experimental results. It has been fixed for further results. So acidic pH support defluoridation. As pH increases, defluoridation decreases. Further studies are conducted at pH 4. So here we could see that the pH is also varied for the defluoridation process, as we could see that we have varied from pH from 2 to pH 12. So here we could observe from the graph as the pH lies between 2, 3 and 4. After up to pH 4, no substantial decline in fluoride absorption, these are the fluoride removal percent, has been observed, but later on we could see that there is a sharp decrease in the fluoride removal percentage, that is up to 40%, which has been observed nearly about pH 7. So it has again confirmed that the removal of fluoride has taken place and the acidic medium fits it well. And further, the beta potential has also taken out, and it was found out to be 5.34, and at 5.34 millivolt, the surface charge of the CP2 remains zero, below which it was quite positive, which attracts negative fluoride ion, which is also one of the important part taking place in the one of the important thing which helps in understanding the mechanism taking place behind the absorption of fluoride by CP2. Further, time is also one of the major parameters which has been varied, and we have observed that nearly about 80% of the fluoride has been defluoridated in the starting 40 minutes of time, but we have equilibrated to 100 minutes, and we have seen that nearly about approximately 100 minutes, nearly about 97% of the fluoride has been removed. At various temperatures has been observed at 298 Kelvin, 308 Kelvin, and 318 Kelvin. Further, various adsorption isotherm has also been fitted. So concentration is also varied in terms of 50 ppm, 10 ppm to 2000 ppm has also been varied. And among that, we could observe here we could see that these are the concentration variation terms at three different temperatures has been varied up to 2000. So here maximum absorption capacity that lies in the region of nearly about 350 something milligram per gram. So it has saturated to that level. So after that, different absorption isotherm model has been fitted, and it was found that the Langmuir absorption isotherm model fitted well with maximum having an absorption capacity of 351.8 milligrams per gram, which also suggests us that the fluoride absorption taking on the CPP2 material is quite monolayer and its chemisorption in nature. Rather than we have also fitted Freundlich and Tankin 2 model, but the R square value of Freundlich and Tankin 2 model was not quite suitable, was not quite satisfactory, but the R square value of Langmuir absorption isotherm model was quite 9.0.996, nearly about approximately for these three of these temperatures. And the similar for the we have studied the kinetic sorry uh, we have studied the kinetics for regarding these absorption isotherms. So we have fitted the pseudo first order and pseudo second order. So here we could see that the pseudo second order fits very well with nearly about R square value having about 0.997, and we could see that the pseudo first order is not quite fitted well, and the pseudo second, according to pseudo second order kinetic, fitted comparatively well with respect to pseudo first order kinetic, with absorption capacity of 60.68, which is milligram per gram, which matches well with the experimental value, which was found out to be nearly about 60.47 something. And after that, intraparticle diffusion model has been plotted. So here we could say that initially it has been fitted very well, and then slope was declined, and further the slope was declined. So this decline, and first the slope was very highly slopy. So the first thing that tells about the initial stages, the outer sphere complexation has been taken place, and afterwards the fluoride has been moved to the inner area, and after that the surface mobilization of fluoride could be observed. Later thermodynamic studies and impact of coexisting ions and reusability has been tested. So as we could see that upon increment in temperature that was varied from 298 Kelvin to 308, 318, 328, 338 Kelvin, we can see that upon increment in temperature, the slight removal in absorption capacity, removal percentage has been quite inclined. So according to it, we could say that it's quite endothermic in nature. Here one top isotherm has been fitted, So defluoridation poses endothermic nature. It ascertains the spontaneous nature of defluoridation, and delta G naught values were found out to be minus 8.95 kilojoule per mole, and enthalpy was found out to be 6.32 kilojoule per mole, and the entropy was found out to be 51.23 joule per Kelvin. Among all those, and these are the different coexisting ions which have hampered the absorption of fluoride over there. So defluoridation has been taken place in the presence of various coexisting ions such as sulfide, chloride, sulfate, nitrate, dihydrogen sulfate, dicarbonate, bicarbonate, and etc. So these are those ions which have been taken place along with fluoride. So among all those ions, the presence of all those ions, we could see that sulfide and bicarbonate ions, these are the two ions which have hampered the most in defluoridation process. So this hampering, this is, you can see that nearly about 67.5% of the fluoride removal percent could be observed in these two ions, especially in the sulfide ions and these bicarbonate ions. Which might be due to the hydrolysis of these ions and making this solution, this water, is basic and medium. Here we could see that as they hydrolyze, the OH ions are generated, which could make this water as basic. So further, it is again confirmed that increase in basic medium, we have again previously discussed in the pH graph that in basic medium the absorption of fluoride is quite poor. So again, reusability cycles has been tested. So it has been looked into up to nearly about 6 cycles, nearly about 53% of the fluoride removal was quite successful. Later on, in order to understand the complete mechanism behind the fluoride absorption spectra, explicit spectra analysis has been carried out, and this is the explicit spectra of overall material before absorption and after absorption. So before absorption, we could see there the presence of carbon, nitrogen, oxygen, and ceria. And after absorption, here we could see that an extra fluoride peak is available over there, which again confirms the successful absorption of fluoride. So here we could see that a peak which is observed nearly about is 684.5 electron volt, which corresponds to the uh, presence of fluoride ion. So this is the XPS of Syria before absorption, and this is the XPS of Syria after absorption. A slight shift in these absorption binding energies has been observed, which has discussed, and in the nitrogen. And here we could see that nitrogen previously it has been shown that there has been binding energy was found out to be 400.4 electron volt, but after that we could observe that a slight shift in at a higher energy blue shift has been seen, that has been shifted to 400.6, which might due to the successful binding of the fluoride with the polypyrrole ion. So polypyrrole nitrogen is also taking place in the absorption of fluoride. So it is also playing a major role in the absorption of fluoride. So it is also assisting in the absorption of fluoride. Here we could see that the OS1 of the spectra, and we could see that there has been slight blue shift could also be observed in this XPS spectra of OS also, O1s spectra before and after absorption. So, which again confirms that there has been a successful adoption of fluoride in the C2P2. Further, this is the mechanism. Here we could see that these are various ions. These are the cerium ions, blue color. This green color, they are the cerium ions present over there. And there has been a vacant site available here, which again generates some unbalanced forces, which is also responsible for the increase in absorption capacity of C2P2. And this also binds it to these ceria particles, and here we could see that as they have bound, there are many groups which is responsible for the absorption of fluoride, such as NH positive, OH2 positive, and here we can see that the fluoride ions has been taken place by the exchange of hydroxyl group by means of fluoride. And here we can also see that the nitrogen present in the polypyrrole ring bears a positive charge, which also in which electrostatic force of attraction takes place between those nitrogen ions and fluoride ions, which are also responsible for the absorption of fluoride. and few electrostatic forces between water molecules and fluoride ions could also be observed over here. So sometimes these vacant sites are also attracts fluoride ions to be for the absorption. Also, this also plays a major role because it has gives some unbalanced energy, which is responsible for the absorption of fluoride. Further, desorption and regeneration has also been carried out. Here, 0.1 molar HCl and 0.1 molar NaOH solution are used for the desorption and regeneration of the spent adsorbent. So CPP2, as we have discussed, that was tested for 6 cycles and nearly about 50% of efficiency is declined. So in order to further conclude, leaching studies is also conducted, ICP OES is conducted, and no substantial amount of cerium leach. Stability and long-lasting nature of CPP2 hybrid material is also curtailed. And in conclusion, CPP2 hybrid material was synthesized via Pechiney's method, followed by successive oxidative polymerization and defluoridation is pH dependent, favored in acidic medium. Langmuir adsorption isotherm model was fitted very with a high maximal capacity of 351.6 milligram per gram. Pseudo-second order kinetics fitted well, indicating chemisorption in nature of adsorption with nearly same experimental adsorption capacity. Thermodynamic characteristics demonstrated the endothermic and spontaneous nature of fluoride adsorption. XPS experiments revealed that CPP2 N positive group acts as dynamic adsorbent in acidic environments. So these are my future work. Synthesis and characterization of other rare earth-based metals such as tin and cerium, magnesium and cerium, gadolinium and cerium, etc. Nanomaterials with more novel adsorbent-based properties could be used for the successful removal of fluoride. Characterize characterization and the synthesized material by using FESM, TEM, BT, TGA, BT, and XPS analytical techniques will be used to examine various physiochemical activities, development of versatile pollutant removal material for water filtration and field application, enhancement in surface area and generation of large number of active sites for better and efficient removal of fluoride, enhancement in the absorption capacity of the material. And last but not least, I would like to thank you very much uh, to my guide, all my colleagues, and International Research Chemistry Awards. And thank you all for supporting me and motivating me. Thank you.